The Leave plan of space experts has found that utilizing our new $10 billion toy, it will be years before that undertaking turns into a reality. On the off chance that it goes as planned, the excursion to Proxima B will take around 20 years. So, reasonably, it will be quite a few years before we can affirm if there is indeed life on that planet. The age-old inquiry of whether we are genuinely alone in this universe endures. The James Webb Telescope has found some frighteningly humanesque things far away from Earth that lead us closer to the response. Our quest for life outside of us has been uncontrolled throughout each human civilization, to such an extent that we have a great many media writings and hypotheses regarding this matter. Our marvel in regards to our place and loneliness in the universe has been constant, as though it is instilled within us to constantly look for a buddy, no matter how alien-like we may be. We may be getting increasingly close to the answers we genuinely need, but are they genuinely the answers we are searching for, or are they significantly more startling? Join us as we investigate the latest revelation in the domains of systems and planets on the journey to track down something we probably won't be ready to observe lights a long ways off. Researchers have found what could be the most momentous discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, a very interesting theoretical inquiry was raised about the capabilities of our technology. The question was whether, in the future, our telescopes could identify artificial light on another planet, such as Proxima B, the nearest exoplanet to Earth. Proxima B, around 4.25 light-years away, was accepted to be perfectly locked with a permanent dayside and nightside, like our moon. A theoretical technological development on Proxima B could move intensity and power from the dayside to the nightside using photovoltaic cells that create power from starlight. Accordingly, in a paper with Manas V. Lingam as one of the scientists, it was shown that huge inclusion of the dayside by solar chargers could be identified with future telescopes. Since JWST was more advanced, it would allow us to expand our search for artificial lights on livable exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope did just that in 2024, utilizing its higher awareness and greater range of abilities, is groundbreaking. The JWST could have found the lights we were looking for and conceivably heaved us into another huge wave of human advancement. Above all, let's dive into the universe of planets and exoplanets to figure out how this was indeed even conceivable. James Webb's mission investigates Proxima B and Peak B's secrets. Since forever ago, humans have pondered the concept of the universe. What we are, where we come from, and where we go. These are normal yet incredibly difficult questions that humanity has attempted to answer. When we gained awareness in the period of outstanding mechanical progression, one wonders whether we are any closer to addressing these inquiries. If you were to ask a philosopher, he could say we are still at level 0 of understanding ourselves in the universe. However, ask a space expert exactly the same thing and watch him jump all over in excitement as he races to tell you the latest discovery people have made about the universe using their clever devices. These instruments, although not given much consideration by the typical public, are directly a reflection of human advancement itself. We now have the world at our fingertips, and it's time we push ahead and get the universe at our fingertips too. One such method for doing that has been derived by researchers and astronomers through the technology we tackle. A particular making of that technology is now responsible for the new discovery of what may be light on an alternate planet light years away. Yes, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation conceived out of the legacies of human endeavors into space to answer some ever-present questions. Are we only who out there? Where do we start and where do we end? This infrared space science device has already started addressing these inquiries. Despite the fact that at first you might get yourself asking what Proxima B is, Proxima Centauri B or just Proxima B is sometimes referred to as Alpha Centauri C. It is a super-Earth exoplanet that orbits an M-type star. Super-Earths could confuse you, but don't worry. This text will settle all your burning questions. Super-Earths are a class of planets that are more massive than Earth but lighter than ice giants like Neptune and Uranus. They are really one of a kind. They can be comprised of gas, rock, or even a mix of both, and their sizes can differ from twice the size of Earth to 10 times its mass. They truly put the super in super-Earth. Regarding Proxima B, it is a super-Earth and an exoplanet, meaning that a planet orbits outside the nearby solar system. The first possible evidence of an exoplanet was seen as early as 1917, although it generated little interest and acknowledgement. However, in 1992, the first confirmed detection occurred, which left researchers astounded. Another exoplanet, first identified in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Out of these, 896 systems have more than one planet. These superb discoveries are circling an M-type star. To understand the M-type star, you need to figure out the red dwarf. A red dwarf is the smallest type of star in the main sequence, hence the name. In the adjoining sectors of the Sun, red dwarfs are by far the most common type of star to be found in the Milky Way. They have very low luminosity, and since luminosity is one of our main tools for planet location and other kinds of allowances, red dwarfs are not so easy to notice. These subtle stars have variable definitions and names depending on their temperatures and sizes. For example, M-dwarfs or M-type main sequence stars yield a maximum temperature of around 3000 K, hence getting their name and attributes. Returning to Proxima B, its mass is known to be equivalent to 1.07 Earths. Curiously, it only takes 11.2 days to complete one orbit of its star compared to our 365.25 days. You can estimate the size of the star Proxima B is circling. Stunningly, under the estimation of the whole electromagnetic spectrum, the star has a total luminosity of as little as about 1.6% that of the Sun. Furthermore, in the visible light range, its luminosity seems to dull significantly more. It only shines 5 to 6% of the Sun's luminosity in the visible light range, transmitting a considerably lesser amount of light energy compared to the Sun. More than 85% of its produced energy is in the form of infrared radiation, circling about 0.045 to 0.056 astronomical units from its star. Proxima B's discovery was announced back in 2016. You may wonder, why Proxima B? With millions of stars, planets, and galaxies, why are we so focused on this particular celestial body? Well, there are a couple of reasons that add to the distinct fascination astronomers have in this place. First and foremost, Proxima B is the closest known star to our Sun, and by definition, although 4.2 light-years is a big number to us Earthlings, in the grand scheme of the universe, it is a mere blip. Hence, why Proxima B, our nearest known star, is high up on the priority list at the moment. It is also part of the triple star system called Alpha Centauri. Moreover, although Proxima's luminosity is very low, the system itself appears as one of the brightest celestial bodies in the night sky, just behind two others called Sirius and Canopus. However, the most intriguing thing about Proxima Centauri B is that it could possibly be habitable, as it falls within the habitable zone. The possible outcomes surrounding the star are endless, and therefore astronomers have taken on the task to explore the depths and limits of the star's potential. That's where the James Webb Space Telescope comes in. The four key objectives of the JWST are to look for light from the first stars and galaxies that formed in the universe after the Big Bang, study galaxy formation and evolution, figure out star and planet formation, and concentrate on planetary systems and the origins of life. As the JWST continues its investigation of the said exoplanet, we get closer to the culmination of these missions, from looking for exoplanets to looking for alien life. So, what exactly is said, one could inquire? Considering that humans have always been a curious species, probing and going into literally everything that moves and doesn't move, it makes sense that a mission like SETI came into existence on such a massive scale. Imagine that God has organized a grand cosmic expedition, but with a twist of gold, we are entrusted with being on the lookout for signals, more specifically electromagnetic whispers from civilizations beyond anything we could ever imagine. SETI, short for the search for extraterrestrial intelligence, is like the world's most high-stakes game of hide and seek, with our planet as the searcher and the vast universe as the seemingly endless hiding spot. It is one of those fields where scientists are advanced Sherlocks, tuned into radio waves and scouring for that subtle, we are not alone moment. This astronomical snooping started vigorously in the 1960s. Frank Drake, a noted astrophysicist, was the first to design and launch the radio telescope search. He proposed that the search for aliens could be narrowed by recognizing radio signals. or electromagnetic emissions that don't belong to anything we know. This is what brought SETI to life. Yet, all these years later, we still haven't received any solid evidence to confirm intelligent alien life. Scientists in the SETI community aren't giving up, though, and recent findings are proving they may be getting closer to a breakthrough. The discovery of signals in the past decade that bear similarity to what we would expect to see from an alien civilization has reignited hope in many SETI researchers. In closing, this thrilling search is as much about our sense of curiosity and wonder as it is about the ultimate goal of uncovering the truth about what lies out there. Whether we're on the cusp of discovering life beyond Earth or not, the journey continues to shape our understanding of the universe and our place in it. The James Webb Space Telescope may have helped us advance this cause, but who knows what the future holds in this quest for alien life? Whether it brings us closer to finding it or something far more strange and unexpected. The ultimate answers may come soon, or they may remain just out of reach. However, the pursuit itself is a testament to humanity's indomitable drive to answer the most profound questions we've ever asked. As humanity ventures deeper into the cosmos, we are pushing the limits of our technology to uncover the mysteries that have long eluded us. The search for extraterrestrial life and understanding of exoplanets like Proxima B have become more urgent as our tools improve and our curiosity intensifies. One of the most exciting aspects of this journey is how it challenges our perceptions about life itself. Are we unique, or are we just one of many civilizations scattered across the universe? As our technological advancements unlock more data, we find ourselves confronted with new questions. What defines life, and how do we recognize it when it is not like anything we have encountered on Earth? A crucial step in this process is examining the atmosphere of distant exoplanets. Instruments like the James Webb Space Telescope, which captures high-resolution infrared images, are helping scientists detect subtle chemical signatures in these atmospheres. This opens a window into understanding their composition and whether they could support life as we know it, or in forms that might be vastly different from what we expect. For example, detecting oxygen or methane on a distant planet doesn't necessarily mean it harbors life, but the presence of these gases in an atmosphere could indicate the planet's potential habitability or even biological activity. Just as Earth's atmosphere is a delicate balance of gases, similar atmospheric compositions on other planets may reveal critical information about their capacity to host life. Another key factor in understanding distant worlds is the study of exoplanet weather patterns and surface conditions. Just because a planet resides in the habitable zone of its star, the region where liquid water can exist, doesn't guarantee that it has the right conditions for life. Proxima B, for example, is subject to intense radiation from its host star, which could strip away any atmosphere or make it difficult for life to thrive. Yet, these challenges also present opportunities for innovation. Scientists are developing new models to simulate the effects of radiation and other environmental factors on exoplanets. These models help us predict what alien life might look like, and whether life could exist in forms entirely different from our own. In the coming decades, it's likely that new missions will enhance our understanding of distant exoplanets. A concept known as the Lunar Gateway could allow for lunar-based telescopes to study the sky, and other space-based observatories may help us gather even more detailed data. Additionally, missions like the James Webb Space Telescope are just the beginning. Next-generation telescopes, such as the Extremely Large Telescope ELT in Chile, will offer unprecedented resolution, enabling us to study exoplanets with even more detail. At the same time, ongoing developments in artificial intelligence and machine learning are making it easier for scientists to sift through vast amounts of data collected by space telescopes. AI algorithms can analyze patterns in light signatures and atmospheric compositions much faster than humans could ever process manually, bringing us closer to finding signs of life beyond Earth. As we push the boundaries of space exploration, we may soon find ourselves standing on the threshold of a new era in which our understanding of the universe and our place within it could change forever. Whether we discover that we are alone or that life exists in unexpected forms, the journey itself will continue to shape the future of science, philosophy, and humanity's collective aspirations as the search for extraterrestrial life continues. The journey is not just about uncovering the secrets of other worlds, but also about reflecting on our own existence. The technological advancements that make these discoveries possible also offer a mirror into the depths of human curiosity and the drive to explore the unknown. For centuries, the idea that we are not alone in the universe has been a subject of fascination. And today, the exploration of space is as much about answering profound questions as it is about pushing the frontiers of scientific discovery. One of the most intriguing aspects of this search is the possibility that extraterrestrial life might not only exist in a form similar to what we see on Earth, but it could also exist in entirely different ways. Scientists are considering life forms that might survive in environments hostile to us, such as the high radiation levels on certain exoplanets, or in extreme conditions like the deep oceans or on icy moons. This could mean life might not be carbon-based, as we are, but could rely on alternative chemistries, such as silicon-based life forms, or thrive in environments we currently consider inhospitable. Moreover, as our tools become more sophisticated, we are finding that detecting signs of life on distant planets may be more nuanced than previously thought. While signs of water, oxygen, or methane may indicate the possibility of life, other factors, such as planetary geology, magnetic fields, and stellar activity, also play crucial roles in determining whether life could exist. Understanding these factors is essential as we refine our search methods. The future of space exploration and the quest for extraterrestrial life will likely rely on increased collaboration between global space agencies, private companies, and academic institutions. This collective effort will enable humanity to tackle the complex challenges that lie ahead in the exploration of the cosmos. As we continue to advance technologically, the mysteries of the universe will become more accessible, and the possibility of finding life beyond Earth may be closer than ever before.